Hey everyone, and welcome to my channel. Have you ever built a microservices application where a single business transaction, like creating an order, needs to update multiple independent services? For example, when a customer places an order, you need to create the order record, process the payment, and initiate the shipping. But what happens if the payment succeeds and then the shipping services is temporarily down? You end up with a paid order that never ships, major data inconsistency, and an unhappy customer. This, my friend, is the classic distributed transaction problem, and in today's video we're going to solve it. We'll be building a resilient order service using Mulesoft and the Quarkus Narayana LRA Coordinator. We'll see how the long-running action standards provide a powerful, flexible way to manage distributed transactions across your Mule and Quarkus microservices. So by the end of this video, you'll understand how to orchestrate a complex transaction where all steps either complete successfully, or if anything fails, everything automatically compensates and rolls back, ensuring your system's data remains consistent. So let's jump right into it, the code, and see it in action. For that, we need three things. First, a Narayana LRA Coordinator. For that, we're going to use a Quarkus distribution as a Docker container. Second, Mulesoft endpoint platform, where we're going to design our three-layer architecture. Third, Mulesoft Endpoint Studio, where we are going to implement our coordinated transaction. Now that we have our LRA coordinator running inside of Docker container, now let's try to send some requests to see how many transactions are actually running right now. And as you can see, the response is empty, so there are no running LRA, means long running action going on right now, and this is where we're going to start with. Let's log into the endpoint platform and let's move into the exchange under our organization, and let's see what APIs we've already been implementing. We have defined two layers, a process layer and an experience layer. Let's look at the other API layer. As you can see here, this is an example request which has a customer ID, a product ID, a quantity, and also the total price. And if we want, we can also test to see what we expect as a result. This is the process layer, and we have the opportunity to use the configure mock service in the endpoint platform to see a little bit how this thing is supposed to work. And the same goes for the process layer. This is only a post request, and it basically has the same request object as the experience layer. The experience layer is there to validate the request and then forward the same request to the process layer, which is where the processing is going to take place. Now that we are done, let's move on to the Endpoint Platform Studio. Now let's open up Endpoint Studio and let's take a look at our implementation. Here we have our orders API, which is the experience layer. And if you look at the path, it's behind the API path, and we have a router, and inside the router we have the flow reference where the business logic is going to be implemented. And let's open our order creation flow Let's look around to see what's going on. Now we have all these Maven packages, and also the definition of our orders API, which is from the exchange. Now it's been packaged as a jar file, and it's part of the resources that are being imported. Now, if we look into our flow reference, so this is where the business logic is. We have a logger, so every time we receive a request, it's going to get logged into the console. Now we have a validation. This is where we're going to check our incoming request and decide whether or not this is valid. And we have our content-based routing. The switch is based on the validation flag, which means that when it's false, we are going to get out with an error message. So we throw an exception. And if it's valid, we're going to send the request to the processing layer, or the process layer actually. Which other folder do we have? We have our configuration folder. This is where we have some defined properties like our port number, where our listener is going to be receiving the request. And this is the outbound call to the processing layer. And when I'm done with the processing layer, we're going to return a message to the caller of the experience layer. So now let's take a look at the process layer. We have our listener configuration, and if we do look at the flow, we have all the error handling routine. We got an in-memory queue where we're going to asynchronously process our request. And as you can see in our experience layer, right, we send the message to a queue, and we process the queue in the process layer. And once the message it's removed from the queue, we start an LRA transaction. We process the order, we make a payment, we ship the order, and then we close the transaction. Now, if we look into the processing order flow, we do have all the callbacks that the LRA coordinator is going to be calling every time we have to handle our distributed transaction. The first thing we do is we do register a compensator to the coordinator. And after we're done registering the compensator, we process our request, then we make a payment, and the payment process is also going to register its own compensating routine. And the coordinator is configured inside, and we have different callback, and the same goes for the the shipping order routine. What we do here is that we also register a compensating routine, and after we've done that, we are ready to ship our order. Now here there is a content-based routing going on, so we're going to check whether or not there is a processing failure. So this is going to be used to simulate an error, and when there's an error, we throw an exception. And the plan is that when the exception is thrown, the LRA coordinator is supposed to be calling all the callbacks that we've configured, right? So there's a flag that we're going to compute based on the incoming request, and we're going to set a specific field that we are going to use to check whether or not this is a request that's supposed to fail or not. As you can see, we are using the customer ID field. So now let's go ahead and start our application and see how we will go about sending our request into the experience layer. As you can see, I've started both layers, which means the experience layer and the process layer. Now let's wait for the two services to be deployed, and up to this point we don't have any error messages. Now the console is already running, and you see they are deployed. Now what can we do? Now let's go over to the console and see how we can test our running application. So this is the our API where we can send the request against the running Mule application. Now let's take a look at the Escalibro to give you some type of overview of what we are actually trying to do. Remember, this is a simulation for a distributed transaction, right? So what we do have here is an experience layer, which is the user-facing API for people calling our services from the outside. This is a typical architecture used in most Mulesoft installation. Usually you have something called an experience layer, and then you have a process layer. The process layer is going to be where the business logic of your application is taking place, right? Now, what we are going to do is the following. So let's assume that we receive a request from a client into our experience layer. So we do receive a create order request. The next thing we want to do is to forward that request to the process layer. But before doing that, what we may want to do would be to validate the request first, and then if there's no error, then we're going to forward that request to the process layer. So we have our validate routine. Now we forward the request to the process layer. Mind you, we do have two different microservices. The first one is the experience layer. This is our facade, as I said, to our user. And when we forward the create order request to the process layer, we are going to be dealing with an asynchronous request processing routine. So the first thing we want to do is to return an order received event or response toward the experience layer. And then we can go ahead and compute or execute our business logic. First thing we do is to create the order, and then we going to be making the payment. And now in our example in Mulesoft, we are going to be calling all this business logic in the same thread, which means in the same process in the same layer. But usually there might be calls to different microservices, but we don't want to get too far ahead of ourselves and make things more complicated than they already are. What we're going to do is to simulate the creation or the processing of a single request in different steps and pretend that every single step might be running into from a different microservices, right? Now, what I'm showing you here is that every single one of these steps has to be happening in the transaction. So our transaction unit spans from the create order request to the product shipment at the end. So the 3-step needs to be in a transaction unit. Traditionally, this typical distributed transaction would be solved by using what's called a two-phase commit. Sadly, two-phase commit doesn't scale. Two-phase commit has to be hanging on to locks. Now, what we are going to be using for our case is this long-running action, long-running activity. It's a protocol for how to solve the issue of distributed transaction efficiently across different microservices. As you can see here, we're supposed to be having our service facade, then our coordinator, which is this LRA process. Then you have service 1, service 2, and the different compensation processes. They might be on the same machine, in the same process, or they might be running on a different machine in a network, like different microservices. The fact of the matter is they have to be able to call back to the compensation in case of an error, right? Now, let's go back to Anypoint Studio. What we do have here, let's take a look at our order processing routine. If there's an error, now this is the experience layer, right? We are calling into the process layer, and in the process layer, as soon as the request comes in, we're going to be reading the queue, start the LRA, then process the order, and in the process order subflow, we are going to register a compensator. This is the callback that the LRA is going to use to accomplish the compensation. The same goes for the payment making function and also for the cancel shipment. So we give the coordinator the ability to call us back in case of an error, so that we can rearrange or undo all the stuff that we have done before the transaction actually get cancelled. So we have to be able to create undoable actions, right? And if you look further ahead, we have a compensation, we have a complete method, which will be called when the transaction is done, and then there's a status function as well, which is going to be called by the coordinator to ask each participant in the transaction for its current status, because there might be a network failure between an LRA coordinator and the different participants. And since all the system might be out of sync, so there is the opportunity for the coordinator to ask every single participant in a specific transaction whether or not they are still alive and what is their status. Have they been able to complete their step of the transaction or not? In which case, they might be canceling the transaction, are actually completing the transaction, right? Now, what I'm showing here is we have, as far as the LRA coordinator is concerned, we have three main functions. The first one is to start a long-running action. This is the first call when we are trying to begin a transaction. It's like transaction begin that you know when you are using the relational database, right? So we start a long-running action. This is an incoming request. Then there is a cancel transaction. So in case of an error, the process that has created the error has the opportunity to call the long-running action coordinator and tell him or let him know that this transaction needs to be cancelled. And then there's also the option to join a running transaction. Now, outgoing request. So once a transaction has to be cancelled, now the coordinator can call back into the running process, right? Here I have my Docker desktop running. I have installed the coordinator running at port 8080 with port forwarding, and this is the Swagger UI for the LRA coordinator. So now let's take a look at all the API that you can use with this coordinator. Now there is the first one, which is a get method. It's going to be returning all the current running transaction, and we can just test something. We are going to create a long run action. We receive a URL with a unique ID for the running transaction. Now there is the opportunity for us to join a transaction. Now, when you start a transaction as a participant, you move your state from the default state to the active state, right? And once the state is active, what you can do is either cancel the transaction or close the transaction. And there's a unique ID to be able to reference a specific transaction as far as the coordinator is concerned. As you can see here, this is a running transaction that we have closed, and then when we request all the currently running transaction, we get an empty transaction back. Now let's create a second transaction. It's going to be created with a different ID, and if we query all the currently running transaction, we are going to get a different result. Now in this case, we have canceled the transaction that we've just created, right? Now I've created another one. It's active. If I take his ID and then I am trying to cancel, now the transaction is canceled. Now if I request all the currently running transaction, as you can see, no transaction is running because the last one was cancelled, right? Now let's go ahead and test our application. So what I am going to do next is to start my application in debug mode, which is going to allow us to follow along step by step and see how the processing is taking place. Now that the application was started, let's send out a request. As you can see, the breakpoint has triggered, and right now we are in the logging processor. You're going to step over and you're going to be in the transfer message and to the content-based router. This is where we are going to be sending the request to the experience layer, right? Because the validation was correct, no issue there. Now let's jump into the process layer where the request is going to come in through the listener, and then it's going to be pushed into a queue this VM queue in which we publish the request and asynchronously return a request receive event. And once the request is out, we can now start processing our requests by reading the process from the queue. Exactly, this is what's happening. Now we are starting a transaction because this is actually where we are defining our transaction boundaries, right? Now I'm calling start LRA. The query is still running. Now let's see whether or not we have a running transaction. Not yet. What I'm going to do is I'm going to step over the call to the LRA coordinator. This is where I'm starting a new transaction. I have just stepped over the start LRA call, and I'm about to process the new order. Now, if we do take a look as far as what are the running transactions that our coordinator has recorded, you can see that by starting an LRA, we have a running transaction, right? And as a participant, we are in the status, or we have an active transaction that we have started. Now, transaction is ongoing, and let's go ahead and get into the processing order subflow. Now, once we get into the flow, we have the opportunity to register a compensation function. And as soon as we do a registration, it also means that we are joining the transaction, because when we are trying to register a compensation function, we also give the current transaction ID. This is called the LRA ID, and therefore we are basically joining the transaction as a new participant, right? As you can see, the effect of registering a compensation function by specifying the transaction ID equals joining a transaction, right? So right now we have joined the transaction. We have registered our compensation function, or not yet. So I'm going to step over, and then you're going to see what's going to happen. Okay, now we have created a compensation by actually joining the transaction, correct? Now let's see how that shows on the coordinator dashboard. So basically what's going to happen is, if there is no error during transaction processing and we close the transaction, then the LRA coordinator is going to be calling this URL, because compensation registration means I am providing the LRA coordinator a URL where he's going to be calling me, right? So now we have joined the transaction, and now that we've joined the transaction, let's try something. Let's take a look again at all the running action. We have one single running action. Now we are in our create order processing subflow. Let's jump into making a payment. And as we are making the payment, we are also going to register a compensator for the payment, right? After we've done that, we jump to the logger, then we make the payment. This is where we are simulating our work effort. After the payment is done, now it's time to ship the order. We are going to jump into shipping the order, into the process of shipping the order, first thing we do is to register a compensator, right? And when we have registered our compensation function, now it's time to process the shipping routine, and in the end we are about to close our transaction because everything went fine, no error, no exception. Now let's take a break and visualize what's going to happen. We have a closed transaction, which is an inbound request as far as the LRA coordinator is concerned. So there was a start transaction, start long running action, and now there is a closed transaction. And when the transaction is closed, the coordinator is going to call all the participants and execute a complete callback actually, based on the registered compensation URL that were given to him when the participant were actually registering the compensation, right? So as soon as somebody closed the transaction, all the complete endpoint based on the registered compensation are going to be called by the LRA coordinator. This is going to give the participant the opportunity to actually clean all the resources that they have used to participate into this transaction. So now let's go ahead and jump over and step over the close call. And you see I've set a breakpoint into the complete payment flow, and the payment was the first to be called or the second to be called, I can't recall exactly. Anyway, the complete callback is being called by the LRA coordinator, right? And now this is something very interesting. What you're seeing right here means that two participants have already started closing their transaction, and there is last participant who has not yet closed his transaction. And as long as the last participant does not close his transaction, the status of the transaction is going to be closing, and you have the list of all the participants that are waiting for the rest of the participant to close the transaction. So basically, based on the result of the participant closing the transaction, you can tell whether or not there are some other participants who have participated to the transaction but have not yet closed. So next up, let us simulate a failure case. As you can see, I've sent a request and I have entered into my customer ID field the fail string, which I'm going to use to simulate an error in my process. First thing that's going to happen is I will start a transaction, I will make a payment, then I am going to, let's check our running transaction first. You see I've started the transaction, there's a transaction that's active. Now I'm about to make a payment and then make a shipment. Now since I've simulated an error by entering the fail string into the request, an exception is going to be thrown. This is just a trick to be able to simulate an error. Now we have the shipment subflow, which is going to throw an exception, and when the exception is thrown, This is going to be a cancel call to the LRA coordinator. So let us step over the shipment flow and look into the message to see what's going on. As you can see, an exception was thrown, and then the different compensation function have been called. And if you look closely into it, as you can see here, so exactly as was the case during the close transaction call, we have here a cancel call that has been triggered by some of the participants. And it turns out not all participants have been called in real time. So eventually the rest of the participants are going to be called by the coordinator to be able to complete their canceling procedure. Now let's look at the different response statuses from the callback that the LRA coordinator is going to trigger. Usually, depending on the type of response that we give back to the coordinator, it's going to decide what the coordinator has to do next. As you can see here, we have a 202, 202 response, and here a 202 as well. And that's the reason why 202 actually means accepted. So every time the LRA coordinator is going to call a compensation function, if we return a 202 error code, we are signaling to the LRA coordinator that we have started compensating, that we are not done yet. This is going to trigger the LRA coordinator to call at a regular interval the status of the different participants. So those who responded to the first call with a 202 accepted response. So this is basically what's going on here. The two participants will return a 202 status are known to the LRA coordinator as in the canceling state. Alright, and until the statuses return the final state of the compensation, the transaction is going to get stuck into the canceling state. And then at some point, when the coordinator is going to be asking for the status, and the participant will return with a completed status to the coordinator, then the transaction will effectively be cancelled and they will disappear from the list of transactions.